Hi there, my name is Rob McCoy of RAM Communications, and in this segment of Telecom 101, we are going to dive into wide area networks. By the end of this segment, my goal is to make sure that you have a better understanding of what wide area networks do and why businesses invest into WANs to help their organizations communicate better with each other. So, without further ado, let's dive in. What is a wide area network? Simply put, a wide area network, or WAN, links separate office locations together. If the WAN is set up properly, staff should be able to communicate with a remote worker in virtually the same time as they can with one of their co-workers down the hall. This is the first and primary goal behind wide area networking. Additionally, a wide area network is a private network. Outside parties are not allowed to use the network without permission. Not only is this important for security, it's also vitally important to ensuring the speed and performance stays at the level that is needed by the organization. So, let's take a look at a public network as a contrast. In a public network environment, such as a Wi-Fi or a cable service, there is little control over usage and therefore performance. Now, what I mean by usage is putting any kind of a cap or control on who can use the network. In a public network, during certain times of the day, that network may perform quickly. However, at other times, when there are many users accessing the network at the same time, then the performance may become very slow, or in worst case, it may be completely unavailable. This lack of performance and security are just a few reasons why businesses invest a lot of money and time into creating private WAN networks. How does a private wide area network actually link separate office locations together? First example that I'm going to show you is one of the more basic older technologies called point-to-point. Now, although it's basic, point-to-point is a very stable and reliable way of connecting locations. In a point-to-point network, circuits can use copper or they could use fiber to physically connect the locations together, as you see in the illustration here. However, a point-to-point network can have certain limitations. Now, for one thing, a point-to-point network can be very expensive and time-consuming to install. Point-to-point circuits are priced on distance. So, depending upon the mileage, that particular point-to-point circuit may be very expensive, especially if I'm trying to connect one location in one city to a location in another city. Point-to-point circuits are also limited in terms of visibility and customization. These are very private and closed networks that are strictly controlled by the service provider. And therefore, these networks don't really offer a lot so that the customer can see what exactly is going on in the point-to-point network at any time. Let's look at an example that was developed as an evolution, if you will, to point-to-point. What we're looking at here in this illustration is a very basic example of frame relay. In a frame relay environment, the technology uses what are called virtual paths between locations. Frame relay uses a packet-switched methodology to transfer data on and around the network. That network and those virtual paths are put together via routers. Frame relay operators control the amount of data passed from each node or location using what is known as CIR, or committed information rate. Once a CIR is assigned to a particular path, it can only be changed via a move-add-change order or a MAC order with the carrier. So in other words, with a CIR, what I, as the customer, have to do is I have to make a determination on how much bandwidth I'm going to allow between locations. Once I have set that in place, that subscription, if you will. That is the limit in terms of how much bandwidth I have between location A and location B. If I ever need to change that in the future, then I have to send in an order with my service provider to change that bandwidth. Moving into today's world here in the 21st century, our networks are becoming much more flexible by replacing physical circuits like point-to-points with virtual ones. Virtual circuits are much quicker to install and they are easier to manage. In the case of MPLS networking or multi-protocol layer switching, virtual paths link locations together, and the bandwidth that is used between those locations can be set up in a much more dynamic fashion. Like a point-to-point link, these paths do provide speed and private connection, but they also do so with much more flexibility and precision for the user. In an MPLS network, specific applications such as instant messaging, voice calls, email, web traffic, all can be prioritized so the most important information gets the most bandwidth. Quality of service, or QoS, is what enables this type of prioritization. And this is why today MPLS is one of the most desired, preferred networking technologies in the business world. Another benefit of MPLS networking comes in terms of visibility and control. The best network providers provide the best online tools so that their customers can see exactly what's going on with their network at any given time. Thank you again for visiting us here at RAM Communications. I hope that you found this segment of Telecom 101 valuable. Stay tuned for our future episodes where, again, we will dive more specifically into the technologies and services that are available in the WAN landscape. Thank you again, and have a great day.